Hello guys, how you doing? Today is the last session of instructing for chapter 3. It's a seventh session. I'm really excited about it. The subject is the energy line and the hydraulic grade line in chapter 3. So follow me with the whole video. So as I told you, the title is the energy line and the hydraulic grade line from section 3.7 of chapter 3 of fluid mechanics 1. This is the last session, but I'm really excited about it. Before going on instruction, I try to introduce myself. My name is Amir Raza Talaqat, and you can email me through address amirrazatalagat@gmail.com. Please don't hesitate to email me and ask your questions about fluid mechanics or any other problems of thermodynamics or heat transfer. I try my best to give you the answers as soon as possible. So, as you know, the Bernoulli equation is actually an energy equation representing the partitioning of energy for inviscid incompressible steady flow in a horizontal line. The sum of various energies of the fluid remains constant in entire of the fluid flow. If we want to use the hydraulic grade line as well as the energy line concepts, we have to represent a geometrical interpretation of a flow that can oftenly be effective to have a better grasp of fundamental process involved. In order to use the hydraulic grade line as well as the energy line, we have to interpret the Bernoulli equation, which is equation 3.7, to the head concept, which means we have to divide the Bernoulli equation by gamma. P over gamma, v to power 2 over 2g plus z is constant along the streamline. Totally is the whole head. In here, we can have the concepts of hydraulic as well as the energy line forms. As you know, every term of Bernoulli equation here is the pressure head, velocity head, as well as the elevation head. The energy line in here is the stagnation point at the end of the pitot tube. It's the energy line. The combination of pressure head as well as the elevation head is called as piezometric head. The pressure static and also the pressure static tap. The velocity head is out of static pressure tap, or in other words, the piezometric head. So it means as we come down, the hydraulic, the energy line is going to be decreased by velocity head to be light on hydraulic grade line. So, there is a concept in this figure either. There's an energy line above. As we come down, the amount of energy line is going to be decreased by v to power 2g corresponding the point. If we be under the if we be under HGL for calculating the pressure head, the pressure head at this side is positive because we are under the HGL. If we go upside, for example here, if we want to have the pressure of 0.2 calculated in this side, it's going to be negative, owing to the fact that it's above the HGL. It's commonly happening in the pipe or any other industrial flows that are dealing with the flows. As I told you, everything is all done. Yeah, Guys, as you know, when the velocity varies based on many factors, such as change in the pipe diameter or in the elevation or in the ingredients of the fluid that it's flowing. So there are some terms that might be affecting the velocity in the pipe. These are the demonstrations that I gave to you in here. Yeah, I've given you all the details, so we can come across an example, which is example 3.14 about the energy line and hydraulic grade line. Before going to having the problem solved, I shall be giving you some demonstrations about one point. Uh-huh. When we are considering energy line as well as the hydraulic grade lines, we are not considering no source, neither source nor sinks, as there are not pumps or turbines involved in this part of the course. But in further, we have to apply them all, which are going to be studied in chapter 5 as well as chapter 8. Here I'm going to solve to you example 3.14. So follow me with the written text. So welcome guys to the last example of chapter 3, which is about energy line and hydraulic grade line of section 3.7. I excuse you, which is example 3.14. The question is, water siphoned from the tank as shown in figure E3.14 through the hose of a constant diameter. A small hole is found in the hose at location 1, as indicated. When the siphon is used, will water leak out of the hose, or will air leak into the hose, thereby possibly causing the siphon of malfunction? As you know, all through this chapter we have already studied flow with steady, inviscid, incompressible, along streamline flow. So so we can use Bernoulli equation. Well, whether air will leak into water or will leak out the hose really depends on whether the pressure within the hose at point 1 is less or greater than the atmospheric pressure, which can be easily determined by using the energy line as well as the hydraulic grade line. As we have total constant head, the energy line is always horizontal. Horizontal always. And we have same areas. So the continuity is same everywhere. So based on hydraulic grade line, which is going to be coming down by the amount of V to power 2 over 2 G's. Based on this concept, we can identify what is going to be happening. If the hydraulic grade line lies below a pipe, which is here, the pressure here is less than pressure of atmospheric. So the pressure of atmospheric goes into hole. Another thing is that yeah, I've tell you everything. There's nothing to be left. I thought it might be something to be left. So guys, welcome to this part, which is the end of chapter 3. I'm really delighted that I have completed instructions of this chapter, because we are in the middle of the whole course. I'm hoping that all of the instructions till here, most likely this session, be helpful to you. And I'm really happy that you have accompanied me till this moment of the video. Please don't hesitate to email your questions or have them commented on the bottom side of the video, and most likely subscribe the channel in order to get the notification of upcoming chapter instructions for chapter 4. I bid you all farewell. See you in the next chapter.